Today we're going to build something cool with shaders that I think is a great way to get our feet wet, and that is color gradients. You might be thinking, we already have access to gradient brushes. And you're right. There are actually a lot of ways to create color gradients in Compose that are pretty straightforward. But we can learn a lot by rebuilding them as shaders. And we get a lot more options for customization by doing so. For instance, I've been into grainy textured gradients recently. I think they look super cool and I want to use them in Android. But there isn't really an easy way to achieve this effect using the current APIs. At least not that I'm aware of. We can, however, build it with shaders, as you'll see very soon. Before we dive in though, I feel like I glossed over a lot in the last video, so let's take a quick detour on our way to amazing looking gradients by doing a quick intro into AGSL. Now, ultimately what a shader is doing is it's returning a color for a particular pixel or fragment. That color is returned as this type here, half-4, which is a 4-dimensional vector that's used to represent that color as RGBA, or red, green, blue, and alpha. So taking a look at this example here, which we see on the right, we are taking the coordinates of a particular pixel and we are normalizing them. And the way that we do that is we are dividing that pixel coordinate by the resolution of the canvas. This gives us our new coordinate, which falls between the range between 0 and 1. Now that we have that, we can actually use it to control some colors. So we're returning a color here, which is, again, this half-4 4-dimensional vector. We're using the normalized X to control the red channel, and we're using the normalized Y to control the blue channel. And we're just setting the green channel to 0 and the alpha to 1. And you can see here on the right that we have this nice visualization of the AGSL coordinate space. So 0, 0 is going to be on the top left, 1, 1 is on the bottom right. As we increase our X value, we actually see more red. As we increase our Y value, we see more blue. And if we're increasing both, we get this purple or magenta looking color. Now we're seeing a lot of weird types here like half-4 and float-2. Just know that those represent like n-dimensional vectors. So like half-4, that being that 4-dimensional vector that I talked about, a float-2 being a 2-dimensional vector, so it holds 2 values. And the difference between like a float and a half is just the precision. So like a float is a high precision floating point and a half is a lower precision or medium precision floating point. So those are all just kind of like semantics for now. I wouldn't get too into it, but just know that these are what the types represent. I want to take a look at this next example right here, which will give us a nice gradient from black to white along the x-axis. So what we're doing here is, again, we are normalizing the pixel coordinate, and then we are just setting this variable here, which we're calling PCT, but we can name it anything, to that normalized x value. Then we're just creating a color and we're setting all the channels for that color to be that normalized x value, and we're returning that color. So if I just change this to that different example and run it, then we see this nice gradient from black to white. And the reason I wanted to go through this example is we're going to be using a very similar technique when we create our color gradients. Now, in order to make a color gradient, we need two things. We need this mix function right here, which essentially allows us to interpolate between two values. In this case, we're using colors, so we have this color A and color B, and this percentage just can represent a value between 0 and 1 to determine where we are in that interpolation, like 0 being closer to color A and 1 being closer to color B. Then we just need a way to interpolate the value that we want so that we can kind of decide how that transition happens between those two colors. In this case, again, I'm just setting it to be the x value of our normalized coordinate space. So we should just get a linear gradient, a linear horizontal gradient between these two colors. So let's go ahead and see what that looks like by going over to our shader code. And I'm just going to set this to color and run it. And if we run it, we see this nice horizontal gradient between this lavender and this dark blue color that I've chosen ahead of time. Let's compare this to the horizontal gradient that we get out of the box. So I'm just going to uncomment this out here, which is essentially just creating a canvas and drawing a rectangle with a horizontal gradient brush that we get from Compose. And then it's using the same exact colors. So if I run this, we can see that we have essentially just recreated the exact same thing. Now that we have it in a shader though, we have a lot more control over this gradient. So let's take a look. For starters, we can change how we interpolate between these two colors. Right now, it's just a linear interpolation, but we can change this to something like x squared for a different type of interpolation between the two values. Before I do that, I'm just going to uncomment out these lines, which will actually help us visualize that function of x. So if we rerun it, we can see now that it's just representing the x function, which right now is just a linear interpolation. But if I change this to power of uv.x and 2.0, then, and I run it, you'll see that we now have x squared, and we can see that our gradient kind of favors the first value a little bit more and is a little bit slower to transition into the second color. We can even take that a step further and control each individual color channel with its own interpolation function. So what I'm going to do here is I'm just going to revert this to be that, and I'm going to uncomment out this line right here. So now I am saying that we're going to linearly interpolate, but for the red channel, I'm going to use this smooth step function, which allows us to just like ease in, ease out, and we'll see that visually. And so let's see what this looks like. I'm running it. So now the blue channel is linearly interpolating, but the red channel is doing the smooth step function. And so we get this interesting effect where there's a little bit less red to start, but then there's a little bit more red as we get past that halfway point. Now we can do something similar for the blue channel. So if I uncomment this out, now the blue channel will be x squared. And if I run it, we get a really cool looking gradient and, in my opinion, a much more interesting looking gradient between these two colors. Now this is cool and all. We have a really good looking gradient here, but this isn't what I want. I want something that has a nice grainy texture. So let's see how we can do that. In order to achieve the look that we want, we're going to need the help of a white noise function. This is going to help add some randomness to our colors. So let's visualize what that looks like. Just going to uncomment a few things out and comment some more things. I'm going to get rid of these, and then let's run it. Okay, and you can see here we have something that looks like TV static because each pixel is just some random value between 0 and 1. And the white noise function here is just a function that I looked up. This is like, if you try to write your own random function, you end up getting something that's not quite that random. So just use this function if you want something that's like white noise. Now that we have this noise, let's apply it to our gradient so that we can get that grainy effect. So the way that I'm going to do that is I'm actually going to use the noise as a multiplier and multiply the color channels by that noise. So if I uncomment a few things out, I'm going to uncomment this multiplier. We'll ignore some of the extra parts for now, but just know that it is a representation of that noise. And then instead of just showing the noise, I'm going to show the color mixed with the noise. But if we run it, we'll notice that we're not actually seeing that grainy texture just yet. That's because we have this factor here, which I'm calling chaos, and that's actually controlled via a uniform that we control at runtime. And right now the value is 0, so it's essentially just canceling out anything that that noise function is returning. But we're actually able to control this via the slider down here. So if we look at the code, chaos is this state that is set to 0 initially, and then we actually use the slider to change that value, which will range from 0 to 1, and then we use that value as a uniform. So let's see what happens as we change the slider value, and look at that. You can start to see that the noise is taking effect. If we move it all the way to the right, it's very grainy, and something like this looks pretty good to me. So this is pretty cool what we've achieved here. We finally got that grainy looking gradient that we wanted from the beginning. So let's go ahead and take this and apply it to something. So I'm just gonna go and go to a different branch really quick, and I'm just going to run that example. Just to show you how we could potentially apply this. So, and I'll make this a little bit bigger. As you can see here, I have a pretty simple button that's actually just setting the background to be that gradient shader that we wrote. And I also hooked up the chaos factor to the on press. So like when I press it, you'll see that it shows more graininess, and release it, it's back to normal. So this is just an example of how you can leverage this and play around with it and see how you can use it in your use case. Now this is a pretty contrived example, but you can definitely make something a lot cooler than this. So pretty pumped to see like what this can unlock for future UI development on Android. We are just getting started here, and there's a lot of cool things we're going to be building with shaders over the next couple weeks. If you're enjoying the content so far, please hit that like button, subscribe to the channel, and tap your head and rub your belly at the same time. Trust me, this is integral to the process. I'll see you in the next one. Bye bye.